And finally, we are in Module 4, Part 2, the final module for this training, and we'll be going over the final two topic, which is data model and the Power Pivot. So data model is an external or hidden database makeup in Excel. So you can store large amounts of data from over 50 to about 100 plus or 50 million or so and so forth. So you can load different queries here, like from customer to product and so on and so forth. It majorly powers the Power Pivot and pivot table, which what gives you the ability to use dashboards effortlessly. So we're going to be making use of table relationship here. We're going to be understanding cardinality, and we're going to be answering, connecting to different tables or to different queries together. Understand filtering or the filtering direction, and with that we'll be done with the data model, and then we'll move on to the Power Pivot. Also take notice that for your data model to work, you must have a normalized data set. Okay, now this is how our data model looks like in real time. The blank pane before shows our table relationship, where we'll do our table relationship, and this is our data view. This is where we would handle our calculated columns and so on and so forth. So for this particular training, the data model is going to focus on the table relationship view. So from our part 1 video, which is on Power Query, I'm sure we'll have already loaded our data into the data model, and this is how our data model data view should be looking like. Not right, our diagram view. So this is how all of the tables are supposed to be, and we'll be moving on to the two types of schemas. So we have the star schema and the snowflake schema. So the star schema involves connecting different lookup tables or dimension tables to the fact or the data table, while the snowflake schema involves connecting data tables to lookup tables and more lookup tables to other lookup tables, or a data table to a data table. So I know what's in your mind, like what is a data table, what's a lookup table? Don't worry, I'll explain all of that as we continue. It's a data table, and what is a lookup table or a dimension table or a facts table? Now, a data table is also referred to as a facts table, and a dimension table is also referred to as a lookup table. So a data table or a facts table is one that has multiple foreign keys, while a lookup table is characterized by having primary keys. So what is a foreign key and what is a primary key? So take, for example, you're at a supermarket, and that supermarket, you are going to buy something in that supermarket for the very first time, and you're buying, let's say, beverages, let's say milk and Milo. You bought milk the first time and you initiated the first transaction. You bought milk Milo the second time and you initiated the second transaction, and then you went back and bought bread. So you've made 3 different transactions in that same supermarket. So a primary key, simply put, is the your name as a customer. You came only once as a customer. It's not as if you were presented. You are 3 different persons. You're the same person. So a primary key is a unique key of just you and your basic information. For instance, your phone number, your age, where you're from, your account details, your account details, your email address. So most people that buy things from online store usually have a drop-down menu where you would impute all this necessary information. So these are stored in primary keys, and these are stored in like a normalized data set called customer tables, where you now have a primary key called maybe the customer ID or customer key or customer something. So they are still product ID, they are still regions ID, as we have seen in this our data set where we have the territory key, the product category key, all of that. This is representing a single person or a single product, and maybe any basic qualitative data. So a primary key is usually, or a lookup table is usually a unique key that has just one single item attached to a qualitative data. So it doesn't have any other value attached to it. It doesn't have duplicates attached to it, rather. And a foreign key is usually attached to quantitative data. Okay, I give an example of the fact that I was a single person making all those transactions. So first things first, when I go the very first day, I'm making 3 different transactions. I'm buying 3 different things multiple times, not all at once. So if I'm going to the cash register maybe the first time, the cash register will give me a particular date I bought that product, and I see that in my receipt and the amount of quantity. Maybe I bought like a full roll of milk the very first time, which is 10 usually here on the side of the wall. So I bought 10 rolls. That is 10 items I bought just now, and I left. I came back again, and then I'm buying another 10 items. That's 20 items in terms of what? Quantity, but in terms of transactions, that is twice. I've come twice and I've initiated 2 different transactions from that store. They give me 2 receipts. Maybe I go again, and then the next thing I'm buying is bread. And then that bread I have bought, the total things I bought in terms of quantity, it is currently 21. And then total transactions I've made is 3 with different dates. The first date will show, the second date will show, and third date will show. Now you can see here that as a customer, I might repeat 3 times due to the fact that I'm having multiple transactions and multiple other quantity. Now that is where foreign keys come in. Now foreign keys are duplicated keys. So you will see a particular customer key or a particular product key repeating itself twice, not necessarily because it is 2 times. It's because of the amount of times somebody came and placed that order. So that's the difference between foreign key and primary keys. And where this shines a lot is foreign keys are now associated with the data table. So data tables deals more with quantity, or fact tables deals more with quantity and like transactions and sales. So you see more of the quantity sold, you see more of the transaction ID, you see more of like different duplicates of the customer key, the product key, maybe the territory key, a particular place that had multiple transactions, multiple sales, multiple quantity sold. Now this is where our normalized data set shines, because with this we can now have filtering directions whereby when a customer initiates, when we want to see maybe how much quantity a particular customer bought, since it is the same key in the primary key, we can link all the qualitative information in that primary key to the quantitative table through our table relationship, and that's what we're going to be doing in this particular data model set and data model part of the course. So now this relationship connection is a data table connecting to a lookup table is called like a one-to-many relationship, where a primary key that has unique values is connecting to a foreign key that have multiple values. So one-to-one relationship is lookup tables or dimension tables connecting to themselves, while many-to-many relationship is many like data table and fact table connecting to themselves. So now, based on the explanation I have given before, you can now see why it is not a very good thing to have both many-to-many and one-to-one relationship, because it's like unique data connecting to unique data. So it's like you're doing the same thing. Why many-to-many relationship is many data, which is quantity, connecting to many data, which is quantity, which is exactly the same thing. So you're only to use this relationship where necessary, and usually to use this kind of relationship, you need a bridge table. So either you break it, have like a star schema that has just a one-to-many relationship, or you can have a snowflake schema that has a star schema and other one-to-one relationship or many-to-many relationship attached to it. So it makes more sense. So that's the typical essence. So the filtering direction is from the primary key entering to the data table, or like the lookup table to the data table, and then it's filtering from the keys. So it's more or less like a downward stream kind of relationship or kind of filtering. On the other hand, a hierarchy is, we'll see more of hierarchies in Power BI, but we're going to do a little demo here of how we're going to use the hierarchy. How our relationship is going to be towards the end of this training, and let's go straight into it right now. Go to our data pane and click show connections. We'll see all our connections, or if you're only showing queries and connections, just click it. All the connections were uploaded from our Power Query video is there. So if we click open data model, you will see our data view and our diagram view. Now you can see at the bottom view, you see all the tables or all the queries that have been loaded into it. Rather, you see the customer, product, report, and so on and so forth. So there are different views. We can add more new files directly here, but to go to the Power Query, we'll come here before we load it, and then to be here, we can refresh our view to see more things. We can find different values. We can create a measure here, and so we can create a calculated column. So this is where we can create our DAX calculated column by just simply clicking that add column matrix by the side. We can also find values here, but what we're going to be majorly focusing on is creating our relationship. All I have explained concerning the data table, lookup table, that's what we are going to be doing here. So we'll spend more time connecting our relationships. Going to be at the home pane. So we can see above there are three other panes: the design pane, the advanced pane. So the design pane gets us access to more measures, which is a DAX version, which will be explained better. Also gets us access to a calculated column. So when we click add column there, it also add column, or we just click that add column, columns cell by the column by the side rather. So we can create table relationships, we can manage relationships, we can edit relationships here, but this will be better seen, or better expressed rather, in the diagram view. So we're going to be heading straight over there, and we're going to be more or less conducting some relationship connections. But before that, we also have different implicit measures that we can use. So we'll explain more on measures as we go along in the training as well. We're going to move into creating actual relationships. So we're going to click diagram view, and when we click diagram view, we'll have this particular pane open up. We're going to rearrange each of the panes. Then we're going to make it start from calendar. Then we'll move on to customers, then product, then customer territory, products, then product category and product regions, while the sales data and the returns data will be underneath. Now the reason why we're doing it like this is we're trying to give the picture of the star schema, or like a downstream flow, where every single value in the primary key is related to a foreign key. So with that, we can now understand the flow that each of the values related in that primary key is relating to a qualitative data. All those data are in turn referring to each of the times when when that particular customer key is repeated in the customer ID, in the facts table, in the sales, or in the returns table. So how to connect a relationship is very simple. We either go to the design pane and we go to and click create relationship or manage relationship, regardless of which we can easily create a relationship, or we can drag click the particular key, drag it to the dimension key point, because we're connecting one to the many. So it's advisable to always drag from the primary key to the foreign key, but in Excel it doesn't matter, but some other platform it actually does matter. So with that, I'm going to stop here, and I want us to follow as how I would be arranging this and creating relationships step by step. We have completed connecting all our tables together. So we can also delete relationship by highlighting that particular line. Now that line that we've connected to different tables is reflecting each of the keys that are connected to each other. So we can delete it, we can make it active, we can make it inactive, we can change all of these things when we click that manage data relationship, as we can see all of that above. This particular table, we have more or less like a star schema. Each of the following, we have multiple star schemas. Each particular table referring to each other has both a primary and a foreign key referencing to another primary key. So above we have the product subcategories having more keys referencing to product categories having one more keys. So a pro tip here, instead of you using one-to-one relationship or many-to-many relationship, it's preferable for you to just append both queries or both tables together, like add them together like what we did in the Power Query, or rather we can just simply create a bridge table or a data table, normalize the data set, and then use that to simply create maybe a snowflakes kind of schema, where we can connect different multiple tables and one-to-one tables or fact tables, but that will still be connected to the star schema structure. Now we are going to be creating a data hierarchy. So to create a data hierarchy, simply put, we can either right click and create hierarchy, or we can click the hierarchy icon at the top of any of the diagram tables. So simply put, a hierarchy is a feature where we can use it to put group items together. So we can use to group items in a table together. For instance, we can group the different dates, we can group the year and the quarter, or the year and the month. So just watch above as I just use the hierarchy. So you can create it, you can rename it, you can do a lot of things with a hierarchy. And with that, we have come to the end of the data model. Now we have been able to create a data diagram view and different relationship with the cardinality of one-to-many. And these are diagram views. So now we are going to be moving on to the Power Pivot. So the Power Pivot is the calculation engine that sits upon our data model. So instead of using normal functions, we are going to be using DAX, which is data analytics expression, to analyze the millions of rows in our data model. Also, we are going to be explaining the pivot table and pivot charts in creating dashboards with calculated column measures and DAX functions. So let's just go into it right now. So a calculated column works solely on qualitative data, while a measure, on the other hand, works on quantitative data. You want to add more qualitative field, like let's say age or different other stuff, you use calculated column. But when you want to add aggregate, you use measure. Take note, it is preferable always to use an explicit measure while doing calculations and not an implicit measure. We'll see different examples as we move forward in the course. Also, you can also do measures in the data model, but it is advisable to do it outside of the data model, and we'll do this step by step in this course. So let's go into it. These are some of the examples of dashboard functions that we work with. We'll also work with the Power Pivot and also use pivot charts, using the relationship I've already created in the data diagram to create interactive dashboards. So I'm just going to now go into it. So we're going to start with creating a calculated column. So a calculated column works in a similar way as our normal functions does, but instead of you referring to the individual cell by cell, we are referring to the entire column as it is. So to initiate it, simply put, we're going to put like an equals to in that our formula tab, same as we'll do in like a normal Excel sheet. And we can do left, we can do date diff minus two different dates from each other, we can do mid, we can do all the normal functions we did in our previous classes. So because in this particular topic, we're just going to go straight into it. We're not going to like show how to use functions. So if you're new here, a particular course outline has been dropped, and in module 3 we discuss functions extensively. So you should pause here and go back to module 3 and watch function usage so you understand clearly. So here I'm just going to allow the demo continue, and we're going to see how we'll create some new calculated columns, and it's going to be really interactive and nice. We're going to create use the normal functions that we use to create qualitative data, and as you can see, we are creating more qualitative columns. We are just adding more things that we can classify to the individual as a whole, like that particular individual. So yeah, so just watch above as I used it. That's I've been able to create my age. So we saw how each of the values were referenced properly. So I'm just going to change it, the title from calculated column to age by double tapping or right clicking, either ways. And then I can move my column, can drag it from one point to the other. At home pane, I can also move it there. So whichever you're comfortable with, we can do that there as well. Okay, now that I've done age, and age was using a date type function, we're going to use a text-based function. For instance, to me, the right and the left that we used a lot in our module 3. We're going to use that here now, and yeah, so just follow the demo along. And with that, we are done with our text-based function. So if we don't really need this column, so we'll delete it and we'll move on to using our logic-based function. So we'll try and create an if statement that if the gender is M or male and is a home owner, like it should print good. If not, it should print bad. So it's just like a quick demo and it doesn't really mean anything. So it just shows the effectiveness of the if statement there. can also use switch here. Initially, I said there are two ways of using switch. There is switch true, and then there is switch with the expression. Now that switch with the expression actually is for here. So we can use that simply instead of trying to evaluate or trying to say, oh, the value should be equals to this. We can just put the table there, and whatever thing we write that the value is greater than or equals to, it's automatically referencing to that table. So that's the beauty of using normal switch. But we can also use switch true to switch true was just created to help us with using normal functions and referring to cells. Since we can refer to the entire table here, we can just use the other normal switch. So we can say an example here that if the expression or the table that we're referring to is the homeowner table, and then if it's equals to n, let's print no, if it equals to y, let's print yes. So we can see how easy we could just select the homeowner expression table and then just put the value. If it's comma no, then move the next one, y, yes, then move the last one, no, if it doesn't fit into any of the values. So that's how beautiful we can use switch here. So we can also use switch true as well. So we can focus on how we can use the demo effectively, as we can see. Also, I keep running into this error because to move downwards to create a space is not enter, it's shift enter. So I keep mistakenly clicking enter instead of shift enter, so it's giving me that error. So that's where that error is coming from. Then, so if you want to enter a new line in the formula bar, just hold your shift and click enter. Okay, now we have seen a demo of switch. We're now going to see a demo of switch true. Also, we can represent the and the or function with a double and sign and a double vertical slash. So with that, we can be able to replicate the and function for multiple components, and then we can also add and or together. So if you noticed before, that was one of the issues we have when we were using and, we use and. When we're using or, we use or. We can't use both together in referencing. So with this and sign and slash sign, we can be able to reference both of them in the same expression pane. So using switch true, we're going to do that demo. So let's just follow along. At the end, to avoid recurring values, we're just going to use only total annual income and profession instead. So with that, we'll have a stable value of mid, low level, and tier. Now, we're about to move to the next demo where we are going to see why we'll say do not perform aggregated functions on a calculated column. Because if you notice, all of these things that we have done are referencing to each individual name. So if we want to maybe, let's say, sum the total annual salaries, and then we want it to reference to each individual. But unfortunately, calculated columns can't be able to do that, as we are seeing above. So this is just a quick demo which will show us that calculated column can't give us aggregated functions or quantitative data, but we can calculate measures here, and I'll show us after we have done implicit and explicit measures. We'll be able to see measures in the data model. You can see the value kept on repeating when we try to sum the total annual income. We're getting the same recurring value again and again and again and again and again and again and again, which ought not to be so. So this is where we're going to use our measures. So we're going to delete this column, and then we're going to go into the pivot table, into the power pivot rather. Next. Now, before we get into the power pivot, we have to first of all understand the pivot table. So this is the data we use in our model 3, the 5,200 rows cleaned data. We've already cleaned the data. So when we're creating that from our dashboard, we had to be using functions, and yes, there's an easier way to do it. I'm so sorry for taking us through that route first, but we needed to understand how all of that worked firstly. So using a pivot table, we can be able to insert all those values that we're looking for. Let's say we wanted to find the product name and the sum of the total quantity, and then the filter will now be the region. Yes, we can use pivot table to easily just create all those dashboards and reports instead of stressing ourselves to be cracking our brains and using functions. Anyways, there are 3 different ways you can get data. There's getting data from table, there's getting data from data source, and there's getting data from the data model. Now, as you can see, the data model is not highlighted here, and the reason because there's no value, there's no information in the data model here. So we're going to be getting from the table, and the table we're going to be using is our clean data set. So we're going to reference the table, the full table. So currently the table is being referenced, so we might not necessarily use this reference, but I prefer always reference your table by yourself. So if you click that arrow icon, it will highlight up, so you can scroll. Please do not touch inside of the cell. We can scroll to our entire table, and then we can highlight the entire table that we want. So the table we're highlighting is from the heading to the end of the heading and to the downward side. So we can achieve this using Ctrl-Shift side and Ctrl-Shift down. So please ensure that your table headers are all occupied. If not, you run into an error here. Okay, so if we have done that, we can now move on to seeing the next pane, and we are going to create a new sheet. It's not this existing worksheet, because this existing worksheet has too many things already. We're creating a new sheet, and we can also add this to the data model if we're working with the data model. But since we're not working with the data model, I'm going to go straight and just click OK, and yeah, we'll see this. So since I've used the pivot table before, my own view is showing like this. So to change your view, you just need to click that gear icon, and you see different views. Now you can see all of our table headers are here, and we can see a filter pane, a row pane, a column pane, and a values pane. So I'll be showing us step by step on how we can reference all of this in a very simple format. And I'm going to be using that example the question that we did for that dashboard, the graph, where we did the product name, and then we'll now sum the quantity. So if we wanted it in the row, we'll put the product name in the row. If we want it in the column, we'll put the product name in the column. So values is the numeric value. You know, when you have your x and y coordinate, you have x value, x1, x2, x2, x3, and then you have the values. So x is going to be like probably in the column or the horizontal axis, while y is going to be in vertical axis, and the values will be on it. So it's the same concept that's working here. So the values is where we are going to experience our implicit measures. We can see above that the product name and quantity sold that we did previously. We're going to replicate this, and we'll see how easily it is to actually do this in the pivot table. At the values pane, you will see something like sum of the quantity. Now, this is an example of an implicit measures, and we can see the exact same value is what is there, but this is monitored referencing to the east. So to make a reference to the east, we're just going to put region, and please, this region is the entire value of each of the column that is there. So we're going to put that region value in there and reference it to the east. Now, if you notice, it's giving exactly the same value as the previous values are given. So this is an easier way to get filters that we were doing last time, and we can still reference it the same way we referenced it in the dashboard before. So yeah, we can also create a new Power Pivot. First things first, we have to go and select our table and all of that. So just please let's keep watching the demo as we take different functions of using the pivot table, not the Power Pivot, sorry, the pivot table. So since it's like the value pane is an implicit measure, whatever you put there is only going to be a count, an average, sum, mean, max, and those are the basic values to give you. So when you put the age now, it's just counting the age. So to see more of the other implicit functions that you can use or implicit measures that you can use, you just right click and you can see all of them down there and scroll. So it is not advisable to use this kind of measure. Why? When it comes to calculating multiple calculations, you will not be able to calculate it. So you will need to get accustomed to using an explicit measure. So for this demo, that's why we're using this, and I'm going to go through some more examples. So just keep following along and you can try it out yourself. Okay, now we'll be moving on to our normal data model view, and you can see there are multiple tables with multiple values. So to create an explicit measure, we just go to the Power Pivot. You see measure there. We'll select where we want to keep it in. So since we're working with quantity, we're going to go to the sales data, name it total quantity or total order quantity, or however you want to do it. Since it's the total amount of times somebody came and ordered something, you can give it a description, or you can just leave the name as it is. So if you notice, you can see there's an equals to sign. So in that equals to sign is just what we usually write in our formula bar. So we're summing and we are referencing this to the sales data's order quantity. So this is going to sum the entire column, and then we can change it to a number, change it to a whole number, click a separator. Separator is a comma in case it exceeded 1,000, and then with that we have created our very first implicit measure. So moving on, we are going to use the same thing to create total returns. I've already been able to create my own total returns. So it's just to put it in the return pane and then sum the total returns quantity. And when we do that, we would have our explicit measure ready as well. And then we have to drag and put it into our values pane. Now you can see in the value pane that total quantity and total returns have already been highlighted. So we're going to try and create total transaction next. So to create total transactions, we're going to count the total order date. From the description I gave earlier about like foreign case and other case, the multiple times an individual goes to buy something, the particular date is indicated in the receipt. So if we count the total number of times a date will be appeared, we'll know the total transactions that was made. And remember, these order dates are linked to the individual customer ID and product ID as well that were in this our data or facts table. So here's an example of the different DAX formulas that we have. There are mathematical functions, there are filter functions, there are logical-based functions, there are text-based functions, there are statistic-based functions, and so on and so forth. You can see all of them above. So measures are more or less filter-based functions and mathematical or statistical-based functions, as well as dates from time to time, depending on as well as dates, yes. But date can work in both calculation tables and also as a measure. While the rest, text functions, as well as logical-based function, work more as a calculated function because it deals more with qualitative data as well. So we're going to be counting the rows, which is also another measure function. So we're going to use count A, which is going to count non-empty cells. So it's going to count normal values, whether date, number, or whatever, it will just count it as it is. So we're going to use that to count the total transaction. So if we count all the other dates, we'll be able to count each and we'll count all of the transactions all together. And we'll be able to also reference them to the individual customer and product key, and as well as the other keys as well. We have our total transactions as our expected measures. Now, after creating the measure, sometimes it automatically just adds in our value pane. So other times we have to go to where we kept it, like now the total transactions in sales data table. So we have to go there and drag it into the values pane. So that's the advantage of an explicit measure. We can reference it whenever we want to and remove it and store it whenever we want to as well. We have access to multiple functions and it's just generally all around better. So please let's get used to using an explicit measure instead of an implicit measure. Now I've gotten the total transaction, total orders, total returns. We also need to get the total revenue, and to get revenue is price times quantity. Now, like I said before, you can't multiply two qualitative data or two tables together. You have to multiply two aggregated functions or measures together. You can think of measures as formulas in a calculator that when you immediately put in a table or put it in a row, or put in this value pane in the pivot table, it automatically comes out. So to get revenue, it's going to be price times the order quantity. We already have total orders as a measure, so now we're going to make price as a measure by calculating this, by summing the total price. And when we put it in this table, it will aggregate as usual. So we're going to keep this in the product lookup pane because product price is at the product lookup pane and it does not make sense to put it somewhere else. So we're going to put it there, and then we're going to sum the product lookup in the product lookup table, the product price, and then I'm going to reference it as a currency and put it into decimal place. The currency that I'm using since is the dollar, so I'm going to use dollar here as well. And with that, you can see the total price of each of the values. Now you can see some particular products with the particular name, like chain and chain block. It had the price, but it had no orders or transactions, so nobody came and bought them throughout their entire sale. So you can even see there are more other products that were not ordered or bought or returned as well. So this is the essence of measures. It can give us this ability to view different fields and be able to create very beautiful reports from the data that we have gotten. And now we can get total revenue. Total revenue simply is the total price times the order quantity. So we're going to leave this maybe that product lookup table or maybe sales data table. Anyway, it's kind of okay. So yeah, so just watch the demo above as we create the total revenue measure. That we have created our total revenue. Now we can see the individual revenue each of those products brought in. We can see because of their price times the quantity that was ordered, we can see how much the company was getting for each particular product. So like I said before, measures can be stored in the data model. So if we go to each of the pages that we have stored the measure, we can see them now. You can see this product being, we're seeing the total price. We can check in the sales data table and we'll see a lot of the other functions. So to create a measure here, you will type out the name, you put equals to and colon, and then you can be able to create a measure in the data model. But if you notice, it's not referencing in the column, it's referencing underneath. So that's why it's preferable to create your explicit measure here than in the data table. Next, we're going to be looking for the total profit. As to get total profit, it is going to be total revenue minus the total cost. So to get the total cost is going to be the sum of all the values in the total cost table. So like with that, now we can be able to minus the total revenue from the total cost, and we're able to get the final answer. That we have gotten the total cost, we can now move on to be getting our total profit. And from what I said earlier, total profit is going to be total revenue minus the total cost. So we are just going to simply use our dash sign to indicate that minus, and we're going to solve that formula, get that total profit measure. Is just going to the new measure and then initiating it. So we will just watch the demo above as we get our total profit measure. Now we can see the value of our total profit there. So we can also replace the product name pane with other values. So it must not just be product name, there are different other values. So you can just watch them above as I just play around with it before we move on to more different other things. Us adding the product category to it, and then we can see all of that. If you notice, the column has headers, and you can see that each of the headers is the summation value that we put in the value pane, which is normal. We're going to look for the return rate or the average returns that each that came in for maybe different months or for different products or however. So what we're going to do is to get the average return rate is the returns divided by the total quantity ordered. So the number of goods that we returned over the total quantity of goods that actually came in that was ordered. So we're going to divide them, and then with that we'll find return rate, and we'll format it as a percentage instead of. So just follow along as we do it above. So we can create another pivot table, and then in that pivot table we'll rank the regions, and we're going to use it from a new function or a filter function called calculate. Calculate function works a little bit like the sum ifs, the count ifs. It's able to itemize total orders, total transactions for a given field. So it has like the measure that you insert and then the filter conditions. So there are some other filtering functions like filter, or filter functions makes it's just like it still does the same thing as the filter function in calculate, but it's much more powerful powerful and it forces the particular value to repeat itself again and again. It doesn't take into account any other value except for that particular value. And all on the other hand, just instead of it to just be aggregating for every single one, it just sums everything together. So there are also some date time functions like dating period, date add. We saw date diff earlier on, so we'll do this subsequently in different other dashboards. As you can see above, we're looking for the Canada total transactions, which is already highlighted in our pane there. So this is the formula. We have calculated the expression. We're using the measure, which is the total transaction, the count of the total transactions, and we're going into the territory lookup. We're searching for Canada. We're saying if in the territory lookup, if country is equals to Canada, let it print out only that as a total transaction. And as you can see, Canada total transaction, only that value was outputted in when we're trying to find it. So the filter condition only checked for, oh, is it Canada? Yes, bring out the total transaction. If not, it just left the rest blank. So it only filtered for just the specified condition. Above, we can see another one. This one is the total profit for just Australia. And now we can see we specify the filter. Now that filter is returning the cost of, when indeed profits is the revenue minus the cost. So it's constantly repeating the cost, because the other values do not outline the specified condition. So it's forcing that filter and it's not like ignoring the rest. It's constantly bringing forth the fact that, oh, this should subtract. But since it did not fit into the condition, it's just repeating the cost. So this was what where I was trying to explain before when I said that the filter condition would read, if you use filter, it will keep on repeating certain values, while a normal calculate function is a simple function that just works based on what is specified. Now we're going to be making use of the all filter function, and like I said, the all filter function brings out the value for all. It doesn't aggregate it, it just fetch it out and bring it for the total. So in case you just want the total, you can use the all function. So we're going to insert a new P4 table, and then we're going to use the all function in this demo. Next, we're going to be working on the dashboard calculations. So like what we did in our module 3, we're going to do that here. We're going to work on certain calculations that we'll be using for our dashboard creation. So we're going to create a plain sheet, and we're going to name that sheet dashboard calculation or dashboard cal, or depending on whatever you want to name it. So first things first, we're going to create 4 different KPIs, which involves the total transaction, orders, average return rates, or return rate rather, and lastly the revenue. So that's what we're going to be using as KPIs. So we're going to create a new pivot table, and we're going to fit all of this in that pivot table. We have created our 4 KPIs. Now we're going to move that into a cell pane so that we can easily reference that in the dashboard like what we did in our module 3. So we're going to write all of that out. We can just follow along as I do all of that. I'm also going to be naming some of the values, and every single thing will be shown in the demo above. So let's just follow along step by step. And after the KPIs, I'm also going to insert the high value customer, the most profitable product, the most returned product, and lastly the most ordered product with their values as well. Also, I'm going to create a chart using the quarter. I'm also going to explain data hierarchy, and then all of these calculations what we'll see in our main dashboard. The same way we reference values in Model 3, the same way we're going to reference value in the Power Pivot or in a pivot table. If you do equals to and touch the value pin, you will see this right up, and if you click enter, that value is automatically going to show. The reason why it's showing get data, measure, and all of that is because it is showing the amount of calculations or the things you need to do. It was a measure that you inserted, and like the name of it, which is total transaction that you gave to it. So that's just what it's doing. So you can do that repeatedly for each value. It's what we're going to constantly be doing. And we can also name this by changing, instead of it being G1, we can change it to transactions. And then when we want to reference it to the dashboard, instead of us like come and be coming back and be equating it, we can just type in the name and then it will automatically just reference. So yeah, that's what we're going to be doing. So let's follow along. Guys, we can also insert our commas and also change the reference of the cell using the home general pane as well. For the currency, I'm going to be using a custom currency, so you can copy my exact custom currency format as we continue in the dashboard calculation above. So you can pause the video here and copy this custom format in currency format rather in this particular revenue pane, because this is what we're going to be using throughout the dashboard calculations for our currency. the 1% person as the highest value customer. Simply put, we'll just click that sort tab, yes, the filter tab in the row label, and then we'll go to value filters, we'll go to top 10, and then we'll select the top one person in the list of the items, the product items, the top one product, the top one person, or the top one other products by the profit, by the all of them is profit, except for returns and then orders. The other one will be total orders, the other one will be total returns. So that's what we'll keep using to get the rest matrix. So moving on, we're going to now start working on the charts. So for the charts, we're going to do a profit trend, a return rate trend, a bar chart of the profit by each region, a pie chart of the continent of transactions, and others. So to do all of that, we will need our two dates. I'm going to be working with the year and the quarter. So we can use a date hierarchy, which is already created, as you can see above. How we created a date hierarchy was already shown before. So we can remove the rest pin and just leave only year and quarter, or we can drag in year pin and start of quarter. And then when we drag in start of quarter, you will see multiple quarter pin. So all you're just going to leave is start of quarter. Either way is still the same thing. So you can try it out there, and we'll move on in our demo. And with that, we're done with our dashboard calculations. Now we have been able to calculate every single thing I said earlier. And now we're moving straight into dashboard creation. Okay. Now we are going to be using cards and shapes and text boxes to create this interactive dashboard. And what will be the key thing that is going to link all our different highlights or key performance index or things that our charts and everything is going to be slicers. So I can't wait, and let's get into it. So these are the colors we'll be working with in this dashboard. These are the hex code, where we can impute the hex code in the color palette. So for some of us that do not have like hex code options, just try and use ChatGPT or use any AI platform to get the RGB, the red, green, and blue code number, and that will work as well. So we're going to continue design the dashboard. Let's just follow along. Those are the colors we're going to be using, and it's just going to be very simple and very interactive. So let's follow along. Also, if you want to reduce the corner rectangle size, reduce it from that yellow ball. So that's how we'll be able to reduce it. And if you want to change the color, you can change it all from the pane above with the shape format pane. So let's just watch it together and follow along, and you can practice this as I am doing it as well. I will be fitting our KPIs, our high value customer, and all those other metrics into these shape places. So let's just follow along as we continue the demo above. So now I've created 4 KPI outpoints. We're now going to create the other 4 for the high ticket high value customer, most profitable product, and the rest still with shapes. It's just to draw a square shape, then copy and paste it 4 times, and then we'll move on to continue with the demo. Also align things vertically so that they will all have equal spaces. Align things center so that they will all have equal spaces, and then distribute vertically so that each one will be, the spaces among them will be the same, and it will be well spaced, well aligned. So we can also align middle, like the top one, what we did there was align middle, and we distribute horizontally. This one we're distributing vertically. So we're going to be using that a lot as we continue in the demo. If we introduce like a text box, we can now start interrelating our fields with the same equals to, yes, equals to that we use in our model 3. So it's exactly the same thing we did in Analyst 3. So that's why we had to first of all get a firm foundation first before we move on. Now we can now move here effortlessly, and this is actually much more easier. So that's why I'm talking less in this video. So let's move on with the demo. And with that, we have inserted our very first chart into the dashboard. So right now we're going to expand it. I'm going to change the color of the line. To change color of lines and of graph, I've done it already in previous videos. So you can go back and rewatch it to understand. But I have been able to outline my own colors to be like this. I shifted it, I removed my grid lines, and then yeah, we're moving on to the next chart now, and just keep following along with the demo. If you don't understand anything, you can ask questions or join the Discord link in the group or in the description. I'm going to also format the bar charts to have the same coloration as our other charts, and I'm going to insert a pie chart as well for the continent, and it's as simple as that. And I'm going to insert on our pie chart. So this pie chart is simple. I changed the color myself. I inserted the circle in the middle saying the continent, orders per continent. So as long as you've been through Module 3, you'll be able to do this on your own. So I'm able to run down the very final pie chart and insert our slicers. And finally, we are now at insight in our slicers. So to insert our slicers, we're going to go to our dashboard calculation. And from there, we're going to click the Python pivot chart analyze. And then we're going to click slicers. Now, slicers is going to ask us, in slicers, it's going to ask us already built-in drop-down menu that we can use as slicers. So we're going to click, we can use either region or country. And if we click it, we can format them, we can change the colors. But for me, I would prefer to use the country because regions are just subsets of some certain countries. So country is going to fully itemize everything. So I'm going to use country as my slicers, and then I'm going to activate the slicers, and we'll see all of that in the demo. I'm also going to format it. We can also create our own slicers color. It's a simple thing. Just go into the slicers color, go to new slicers color or theme, and then we'll see that there. And then we can copy or cut our slicers and take it to the dashboard, and then we can have our interactive dashboard. And yeah, with that, we are done. Now we have our interactive dashboard with our slicers. And whenever we outline each of them, we can see that we have a very fully interactive dashboard, which is really cool. So we can just still play around with this. You can change some of the metrics. If you're following along with the course, there is going to be an assignment and you have your own valuations to create the dashboard however you like. So you don't necessarily need to follow every single thing that I did here. You can put your own initiative and your own ideas to it as well. And yeah, finally, we are done with Moodle 4 dashboard and report automation. So I hope you have been following. I hope you've learned a lot. And finally, if you're following along, there will be a link dropped that will have the Moodle 5. The Moodle 5 is actually going to be an assignment where you will be creating your own interactive dashboard. So you can check the description on this video. And also don't forget to like, subscribe, and share this with a friend that you feel like will need it. And we'll finally come to the end of our training and with the beginning from Excel to data analysis in yeah, basically. So thank you for being a part of it, and see you later in my next video. Bye for now.